Yeah. So like we've said already, we are going to look at this is actually under units and measurements. When you're looking at units and measurements, and then under that units and measurements, that's where we also look at how to convert units, because you can have units that are in different subunits. Let's say, for instance, when you talk about time, you can have time in hours, you can have the same time in minutes, you can have the same time in seconds. So you use the conversion factors to be able to convert. And then on the same, especially in chemistry, you look at significant figures. Okay, so you look at significant figures. So we're going to look at significant figures. What are significant figures? And then we're also going to look at the rules that we can use to determine if a number, a digit, is significant or is not significant. Okay, so when you are talking about a significant figure of a number, you are just talking about a digit that is carrying a meaning. Okay, a digit that is carrying a meaning, not only a meaning, but it is also contributing to the precision of that number. Okay, so a significant figure, that is, if you are writing significant figure of a number, is or are digits that carry meaning. Okay. So a significant figure of a number is or are digits that carry meaning in a number and contribute to its precision. So if you have a digit, you have a number, and in that number you have digits that do not contribute to the precision of that number, then those digits are not considered significant. Those digits are insignificant. Okay, so these digits in a number, they are supposed to carry a meaning, and also not only carrying a meaning, but contributing to the precision of that particular number. So what are the rules? What are the rules of determining if a number is significant or not significant? Okay, I haven't finished writing that one. Okay, so rule number one is that all non-zero digits, number one, all non-zero digits are considered to be significant. All non-zeros are considered to be significant. So if you have, for instance, you have 1, 2, 4, 5, maybe a point there, then all these numbers are significant. All these digits here in this number are significant. So when you are counting the number of significant figures in this number, which is 12.45, we have 1, 2, 3, 4 significant figures. So all the 4 digits here are significant. Even if you have also, you can have, also here, we are saying we have 4 significant figures. If you have 3, 56, 7, 9, these are non-zeros, okay, non-zero numbers. So here what we have is that all these numbers, all these digits in this number are significant. And since all these numbers are significant, all these digits are significant, meaning that 1, 2, 3, 4, 5 significant figure, then this has got 5 significant figures. Okay, so rule number 1, all non-zero digits are significant figures. Okay, we go to number 2. Rule number 2 is that all zeros, okay, all zeros appearing, maybe not all, but zeros appearing between so let me even erase. Oh, so we just say zeros appearing between 2 non-zero numbers or digits. Oh, let's not confuse numbers and digits here. So let's say, let's not confuse 2. So zeros appearing between 2 non-zero digits are significant. Okay, so zeros appearing between 2 non-zero digits are considered to be significant. So let's take, for instance, if we have 205. Example, we have 205. You have 10.03, like that. Since these zeros here are appearing or are between the non-zero digits, then they are also going to be significant. So what you have here on the first one, the number of significant figures in that number, the digits of significant figures, we have 3 significant figures. And here we have 4 significant figures. Okay, so figures, yeah, something like that. Figures. So that is our number 2 point. So we have point number 3, we have leading zeros. Okay, leading zeros, and these leading zeros, we are just talking about the zeros before non-zero digits. And these are not significant. So these rules are going to help you a lot. They are helpful for you to know, even when you are calculating, especially when you are calculating, you are dealing with the calculations in chemistry, in physics, you need to know the significant figures and what kind of the answer you're going to get. You're going to see as we'll be applying this in terms of multiplication, addition, what are the rules that you take when you don't just multiply and get the answer. No. You have to consider the significant figures of that number or of those numbers that you are multiplying. Okay, so leading zeros or zeros that are found before non-zero are not significant. So for instance, if we have 0.0015, okay, these numbers or these zeros, I mean, are not significant. The only significant digits here we have is 1 and 5. So here what we have is that the whole of this, we only have 2 significant figures. Okay, so all zeros that are found before non-zero digits are not significant, are not considered to be significant. And then we go to number 4. And number 4, we are talking about trading zeros after non-zero digits. Okay, so trading zeros, when we're talking about trading zeros, we are talking about zeros after non-zero digits or numbers. Now, these trading zeros, if there is no decimal, without decimal, without a decimal, then generally not significant. Okay. So if you have trading zeros, you have maybe a number or a digit, a non-zero digit, and then that non-zero digit is followed by zeros without a decimal point, then those zeros are not considered or cannot be considered to be significant. Let's say, for instance, we have 300. Since there is no point here, then these zeros are not significant. So what we have here is one significant figure. The only digit that is significant here is the only digit that is significant here is just the 3. Otherwise, these other ones are not significant. Okay. So we go to number 5. Number 5, we're saying sharing zeros in a number containing a decimal point as significant. So if we have maybe 12.2300 like that, what we're going to have is all those zeros are considered to be significant. The 2 zeros there are considered to be significant. Why? Because of the decimal point that is existing here. So here we're going to have 1, 2, 3, 4, 5, 6 significant figures. 6 significant figures. Okay, so that is number 5, and point 6 also that we have also to consider here is that zero itself, or the number, let me say the number 0 itself, okay, has a significance of 1. Significance of 1. So if you have, for instance, you have 0.00, this is going to show you that those are significant. Okay, those are significant. So you have 3 significant figures, and we have that point there. And then the last one we have is about scientific notation. Okay, so the numbers in a scientific notation are considered to be significant. So if you have, for instance, you have 4.300 by 10 to the power -4. Yeah. So here what you have is that you're going to have, even these zeros are significant in this case. So you have 4 significant figures. Okay. So that is about the rules that you use to determine if a number or a digit is significant, or how many significant figures you have in a given number. So these are the rules that you use. Now, we do a lot of calculations. We do a lot of maybe addition, we do subtraction, we do multiplication, and all that, division. Now, how do we carry out those calculations? Okay, with the consideration of significant figures. So number one, when you are multiplying, and dividing, so this applies to both multiplication and dividing numbers the number of significant figures used is determined by the original the smallest So when you are multiplying two numbers or you are dividing two numbers, the answer that you should get, it's going to be influenced in terms of the number of significant figures of that answer. It's going to be influenced by one of the two numbers that you've multiplied. Now, this number that is going to influence the answer will be the number that has got least significant figures, least number of significant figures. Okay, so we'll look at that. But when, for instance, you have okay, can I think of numbers? Okay, let's say we're multiplying 2.346 times 1.2. Okay, so what do we get when we multiply those two numbers? 2.346 times 1.2. So what we get is 2.8152, like that. But if you write like this as a scientist, then it's wrong. Okay, it's very wrong. Okay, you have to follow the rules. So since you are multiplying, you have to get the least here. This one has got 4 significant figures, and this one has got 2 significant figures, meaning the answer that you have to get should have 2 significant figures, because we are following, or the answer is being influenced by the one with least significant figures. Because remember, we are trying to be precise as possible. Okay, we want to be precise as possible. So for the sake of precision, we get the one with the lowest number of significant figures. So this answer here is supposed to be 2.8, which has got 2 significant figures. So this is what you do as you are when you are doing the multiplication or division. That's what you do. And then the last one we look at is when adding or subtracting. Okay, when adding and subtracting, the final number. Yes, please.
Sir,
yes.
Just on that, okay, I decided instead of you writing the points, you'll be just saying I'll be writing, because it may delay some time.
Okay.
How is that?
Okay.
Yes, I'll be writing the point because I'm fast.
Okay. Okay. So actually, it's the last one. It's the last one. When adding and subtracting, the final number should be rounded. So this is the last one, to the nearest or to the decimal. Of the least precise number. Okay, so I've run you through on the rules which you use in terms of knowing this number of significant figures when you're multiplying, when you're adding, what you need to do to the answer. Okay, so here now we look at some of the examples, or we solve some questions. Okay. So we're looking at this question. We have determined the number of significant figures in the following measurements. So the first one that we have A. So this is going to be pretty easy because we've gone through this. So we had a point where we talked about the numbers that are the zeros that are trapped, or trapped zeros. So if we have zeros in between non-zero numbers, then they are considered to be significant. So what we have here, all the zeros in this number are significant. So we have 1, 2, 3, 4, 5 significant figures. Okay, and then we go to B. B, how many significant figures do we have in B?
It's 3.
Here we have 3 significant figures. So these here are not significant, but these 100 are significant. So there we have 3 significant figures. And then on C, 3000 kg.
We have 1.
So here we have 1 significant figure. Only 3 is significant. We've looked at these things. And then this one is D is supposed to be 3.710 times 10 to the power 5 atoms. Okay. So the number of significant figures here are actually 1, 2, 3, 4 significant figures. We've looked at that. I think it has to be point number 7 or point number 6 or so. Okay. And then on the last one, now I didn't talk about the last one. I didn't talk about the last one. I didn't touch the last one, but you can have such. Okay. You have 5,000. 5,000, and down there you can see that there is a point there. So that shows you that only after the point, what you're going to have, or the zeros that you're going to have after that point, are not significant. But what you have before that point is significant. So what you're going to say is that you have 4 significant figures. Even these zeros are significant because of that point that is there. We have a point there. So here we have 4 significant figures. Okay. So that is how we get that. That's how we get that one. And let's look at another example quickly. It's saying evaluate Okay, so we have this one that is saying evaluate the number, the following, and write the answer to the appropriate number of significant figures. So we have our A. Let's look at A. What A says we have 8.337 times 10. This has to be to the power 16. And then we are multiplying with 7.202 times 10 to the power negative 29. Okay. So you do the normal multiplication, and here, what you just consider is the number of significant figures. You look if you have a number that has got less significant figures, and that is going to influence the answer. That answer that we're going to get must have those significant figures. So now, the answer that we are getting is, all right, the answer that we are getting here. So we have 6.0043074 by 10 to the power negative 12. Okay, so now we look at the number of significant figures that we have. So we can see that both numbers have got the same number of significant figures. So, and this number of significant figures is 4. So even our answer must have 4 significant figures. And the 4 significant figures, it will be from there up to here. So if we had a number that was 5 and above, we're going to round off. But since the number next to 4 is 3, we're going just to get 4 the way it is. So we have 6.004 times 10 to the power negative 12. So that is the answer. If you write the whole of that, then you are wrong. Okay. So we got to B. B is we have 9.803 times 10 to the power 13. Okay, and this we are multiplying by 2 times 10 to the power negative 5 and dividing by 4.56 times 10 to the power negative 32. So we have to do this step by step. We start with multiplication, or the numerator. We multiply the numerator, and then we come to division. But all in all, we will have to remember the same rules which we use on multiplication and also division. Actually, division and multiplication, we have the same rule. Okay, so what do we have? We have 9.0, 9.803 by 10 to the power 13. And then we're multiplying it by 2 by 10 to the power negative 5. So on top here, we have, we have 960600000, like that. So now this one, we have to express it in a standard significant figure as the answer, since we've multiplied. Now we look which one has got the least significant figures. So it is this one which has got 1 significant figure. So meaning this answer is supposed to be a 1 significant figure answer. So what we do, we express this in scientific notation. So we have from here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Excuse me. we have 9. Okay, so since we want it to be a one significant figure and the number here is more than or is bigger than 4, then we're going to round off, which is going to be 2 times 10 to the power 9. Okay, so that is the answer. So here now we're going to have 2 times 10 to the power 9 divided by 4.56 by 10 to the power negative 32. So we do the same procedure. Okay, so we have 4.3859649 of times 10 to the power 40. So we have to express also this. We have to write this properly as people who know the rules of significant figures. So the least one that the least significant figures is the numerator, that is one significant figure. So even this answer has to be one significant figure. So we're going to have 4 by 10 to the power 40. Okay, so like that, then we'll have solved that one.